Now let's look at a sample question. This question is from the textbook on page 133. This is a process. It's a customer passenger arrival process at JFK Airport. The arrival process includes 6 different activities, and from deplane all the way to boarding the domestic flight. And we also know the cycle time for each activity in terms of seconds. So let's do this. First of all, let's do the original flow chart. So it's a very simple flow chart. 6 different activities. That means I have 6 different rectangles. Each one represents one activity. So 1, 2, 3, 4, 5, 6. On the bottom, lower part shows the cycle time for each activity. It's a copy paste from the previous table. So activity 1, cycle time 20 seconds. Activity 6, cycle time 15 seconds. Next, we want to fill the right-hand side. Basically, we want to figure out what's the capacity for each activity. So we know, given the cycle time, we can calculate the capacity, which is 1 over cycle time. So for activity 1, 1 over cycle time 20 seconds. So we want a capacity to be capacity per hour. That's why we convert seconds to hours. 20 divided by 3600. Then this is equivalent to 3600 divided by 20 per hour. So we have 180 per hour. So that is the capacity for activity 1. For the rest of activities, you can do the similar calculation, but basically want to skip some steps. I don't want to go over write down everything here. What I will do, I start from the last line. I just use the last line. So for second activities, it's basically 3600 divided by 12. 3600 divided by 16. 16 is a cycle time in seconds. So the capacity is 225. For activity 3, capacity is 90. Activity 4, 150. 5, 200. 6, 240. So we use cycle time to calculate the capacity for each activity. Now we want to figure out which activity is a bottleneck. So how do we do this? There are 2 different ways you can identify a bottleneck activity. One is you compare the capacity for all the activities and look for the smallest capacity. That's one way to do it. Or you can focus on cycle time for all these activities. Look for the longest cycle time. Okay, so these both methods will give you the same solution. So if you look at capacity, you can see activity 3 has the smallest capacity 90 compared to any other numbers. So that's why activity 3 is a bottleneck. If we look at cycle time, you can see 40 is the longest cycle time compared to any other cycle times. So 40 is the longest one. This means activity 3 is a bottleneck. So either way, either look at capacity, the smallest capacity, or the longest cycle time. It gives us the same conclusion. So activity 3 is a bottleneck. So that means what? Bottleneck activity 3. And the system capacity is 90 per hour. System capacity is equal to the capacity of the bottleneck activity, so 90 per hour. Question, what if we double the capacity of the baggage claim area? So add more capacity, double the capacity here. But doubling the capacity for activity 3, can we double the capacity for the entire system? So if we can increase 90 to 180, can we double the capacity for the entire process? Think about it. The answer is that no. Okay, by doubling the capacity for activity 3, the bottleneck activity will shift. The bottleneck activity will no longer be activity 3, it becomes the activity 4, 150. So that's why if we only double the capacity for activity 3, the capacity for the entire system will not be doubled. It will not become 180. Instead, it becomes 150. Okay, this one will become the new bottleneck activity, activity 4. So activity 4 will be the new bottleneck, and the system capacity will be 150 instead of 180. Okay. So the natural question is, then how can we double the capacity for the entire system? How can we do it? As we see in the first example, we may need to restructure the process by grouping activities. Okay? There might be a way to do it. So let's take a look. This is how we can do it. What if we combine activity 2 and 4 into a single activity and schedule 2 people to handle the new activity, schedule 2 people to handle activity 3? So this is what it means. I still have 6 different activities, but I group 2 and 4 together, having 2 people handle the new activity, and at the same time, having 2 people handle activity 3. So how many people are needed for the new system? So 1, 2, 3, 4, 5, 6, 7. So I basically need to hire 1 more person. At the same time, I restructure the activities. Now let's do the analysis. First of all, let's look at cycle time. The cycle time for 1 will be the same, 3 will be the same, 5 will be the same, 6 will be the same. But 2 and 4, because it's a new activity, we group activity 2 and 4 together, the cycle time will be different. So how do we calculate cycle time? We simply add the cycle time for 2 and 4 together. That will become the new cycle time. So 16 plus 24, 16 is the cycle time for activity 2. 24 is the cycle time for activity 4. So we added them together, 40. 40 is the new cycle time for the new activity. So given the cycle time, we can also calculate the capacity. So how to do it will be 3,600 divided by 40. So you get 90. So 90 per hour is the new capacity for the new activity. So now we have a complete flow chart. So in order to perform the analysis to identify the bottleneck, we may want to convert 2 boxes into a single box. Okay? To make it clear, convert 2 boxes into a single box. So here, I have 2 people to perform activity 3. With 1 people, cycle time is 40, capacity is 90. So if you have 2 people, what's the equivalent cycle time, the capacity? So equivalent cycle time capacity will be 20 and 180. So the cycle time was 40, with 2 people, it's faster. So that's 40 divided by 2, with 2 people. So new cycle time is 20. The cycle time for the capacity for 1 person is 90. So with 2 people, you can double the capacity. So 90 times 280. So that's the new capacity. That's the equivalent capacity. Same thing for the new activity 2 and 4. So cycle time will be half, 20. Capacity will double, will be 180. So now let's look at the process. I have stage 1, 2, 3, 4, 5. We try to identify the bottleneck. So here, let's look at the capacity. Look at which one has the smallest capacity. This one has 180, 180, 180, 200, 240. So clearly, these 3 stages are the new bottleneck activities because they have the smallest capacity. So, but they are the same, 180. They all have the same capacity, 180. The bottleneck activity will be 1, 3, and a new activity 2 and 4. So because they have the smallest capacity, 180, or another way you can look at it is you can look at the longest cycle time is 20. So 20 compared to 18 and 15.